again. Calculations you checked once. I've just shared my idea here, my view on this question. So what is telling? There are two plane mirrors are there of length L each, are separated by again distance L. So L by 2, L by 2 with respect to this bisector. A point source S is kept at the distance L. Fine. A person moves along a line AB with a constant speed U. Find the duration of time for which it is image of source S in the mirrors. I think that this will be better viewer. Okay, no. Again, the idea is same, no? Like already we had a discussion. So what we do is like where the image will be formed. First, we'll get the location of the image. The image will be formed. Object distance should be equal to image distance. So the image will be formed. So this is the position of the image. The position of image will be formed. I feel very challenging these things are drawing a diagram. Little bit I had to struggle. Okay, now we'll take the straight line. Okay, let me. Okay, after this will be incident tree. Oh, this will be the diagram. Then the brown color one I'll extend from here. Okay, I think you are able to see very nicely the reflected rays. He's asking that particular distances. This is the ray. So maybe no. Okay, this is the source. Okay, we'll take this is A. This point as B. This is P. Let this be C. Let this be D. And let this be, say, like a E. Again, do we have any help? So he's asking find the duration of time for which it sees image of sources in the mirrors. So the person is moving along the line AB with a constant speed U. So the moment as it traverses from C to D, the person is able to visualize the image I. Any reason for that? Or shall we take ear also? Yes, ear also is possible. No? In this region, there are no reflected rays. There's a reflected rays here also. We should draw another set of diagrams here. I have to shift the complete diagram. Okay, let me try. Oh. Hope I can now give a better diagram. But let me draw the another ray. Then let me take that picture. Yes. Yeah. Similarly, oh God, we don't have space. Okay, I'll try to explain through verbally, if not diagram possible. Okay, we got it. I'll change the size of the mirror a little bit. Okay, we can do it. For our understanding purpose, we have made it. Yeah. Now this will be the discussion which we are supposed to continue. Okay, I'll do one thing. Okay, I think I'm successful. Okay, able to see the diagram complete description. Okay, now we'll get into the discussion. We have to calculate this distance. So I'll write C1, D1. We have to calculate C1C and D1 from the data. Hope everyone is able to understand. So this much of data is we are supposed to calculate here. Okay, now so it was a diagram. So finally, what happened? I'm able to get a better diagram. So he's asking this distance C1 D1. For what time the person will see the image of sources. So what is the field of view? So this is the field of view. This is the field of view. This is the field of view. So we have to calculate C1C and D1. Okay, let's calculate first what is C1E. I'll calculate CE. If I subtract, I'll get the C1C. And since C1C is as source as is lying symmetrically with respect to this, so what this distance must be equal to this one. Okay, let me take the help of the triangles. We have a set of triangles here. So the triangle, look at the similar triangles like API and API and the triangle CEI. So tan alpha, this will be CE by 3L, or let me write EI. This should be equal to AP by PI. So what is CE? CE we don't know. Unknown thing. What is EI? 3L. AP is L by 2. LI is L. So CE should be equal to 3L by 2. Please follow this. Now look at this triangle. Tan alpha, what you can write tan alpha? AP by, so like it's CE by EI. Similarly, what is tan alpha? AP by PI. Oh, so some are asking, sir, how you are writing? from tan alpha. Similarly, look at the similar triangles. A1, I'll write it. This is B1. So from triangles, A1 PI, then B1 PI. Okay, from these triangles, so tan beta, you can write it as A1 P by PI and C1 E by EI. So this should be equal to what is A1 A1P. A1P will be 3 like a L plus L by 2. PI distance is what? L. C1E. What is EI? EI will be 3L. So what is C1E distance should be equal to 9L by 2. C1 is 9L by 2. So we wanted distance C1C. So these are the two set of calculations. Okay, how to get the distance? C1C. So C1C should be equal to C1E minus CE. I don't have space, so I'll have to adjust here only. C1C should be equal to C1E minus CE. C1 is 9L by 2. This is 3L by 2. So this will become 3L. Similarly, what all we calculated, C1C should be equal to DD1 from the symmetry of the diagram. Even these angles will be same. So no need to calculate, the same thing is applicable. So therefore, what is the total time? That should be equal to C1C plus DD1 by U. So this will become 6L by U. For this interval of time, the person is able to see the image. More about the geometry, nothing big. We can manage the drawing, ray diagram, all. So on paper, you can draw very easily. On my computer screen, that lines to be adjusted little bit. It's taking time. Other on paper, you can work out very easily. So always maximum look out for that similar triangles. So this is the field of view. That this, in short, will write field of view for the upper mirror A1, field of view for the lower mirror BB1. So the person will be seeing, as long as he's here, you will see the image. Then as long as here, you'll see the image. But there'll be only one image, not like two images.